Today topic is about statistical analysis of data. What is statistical analysis of data? Why we are going and statistical analysis of data. Statistical analysis of data, it is nothing but it's a procedure for performing various states of operation. That is what statistical analysis. We are going to do some procedure out of which we are going to calculate the status of data. Not only that, using statistical analysis, we can able to quantify the data. Whatever the data, we are going to use it in the measurement system that can be quantified, as well as we can do some survey of observational data. That is the main purpose the people used to go for statistical analysis. And while you are doing statistical analysis, we are having so many operations. That is what we are going to see in today's class. Before getting into statistical analysis, generally this experimental data are obtained through two forms. The first one is called SST, the another one is called MST. SST, which is nothing but single sample test. MST, which is nothing but multi-sample test. So from the word you can able to understand single sample test, which is nothing but we are just going to read the value using same equipment, that is single equipment. Using the same observer, we are going to evaluate the same procedure. So all the things will be done through a single. But when you are going for multi-sample test, it is totally different. We are just going to do with a repeated measurement of a given quantity under different test condition. That is what MST talks about. So using this MST, we are having different instruments, different observers and different ways of measurement. Why we are going for multi-sample means just to get a correct results. That means we are supposed to get a nullified value out of this multi-sample test. So the people used to go for multi-sample only. They are not preferring the SST, that is your single sample test. So while you are going multi-sample test, what are all the statistical analysis we have? There are so many statistical analysis. The first one is arithmetic mean, standard deviation, mean, standard deviation of mean, standard deviation of standard deviation, then probable error. There are so many types we have. So what is the meaning of arithmetic mean? Arithmetic mean, which is nothing but we are just going to average out of sum of the observation, which is nothing but the most probable value of measured variable is the arithmetic mean of the number of readings. Next one is called dispersion. So from the word we can say it is a scattering. What does it mean? Scattering or spreading of the values about the central value. That is what called dispersion. And using this dispersion, we can able to indicate the degree of precision and the regularity of the data. The third analysis is nothing but range. Range means it is nothing but it specify the value from the lower to the higher. But span is different that of range. Span, which is nothing but the difference between the higher and the lower limit of the recommended input value. So you should have a good knowledge on range as well as span. Both are different. Next one is about the deviation. That is nothing but departure. That means the difference between the observed value from the arithmetic mean. Because x bar you can able to calculate it through all the observation. But deviation, that value should be subtracted the single observation from the arithmetic mean. That is what deviation talks about. Then next one is about the average deviation. What is the meaning of average deviation? It is the average of modulus of individual. So you have to calculate the different individual of your deviation value. After calculating the deviation, you have to take the modulus. There will be a positive and the negative, but you have to take only the modulus. That means what? Whether you are getting negative value while you are taking an average thing, you have to get a positive. So you are not concentrating on the negative thing. Okay. So the average deviation, which is nothing but summation d squared divided by n. So from that is the way of calculating the standard deviation. The next one is about sigma. How we are calculating standard deviation. So there are two things you have to denote. One is the standard deviation term. We are using sigma as well as s. What is sigma and what is s? Sigma means, which is nothing but whatever the number of samples you are going to have. If suppose the number of samples is less than 20, then which is call it as an S. In that we are using the letter of standard deviation is S. If n is greater than 20, the value is greater than 20, then the term we are using is sigma. So sigma, which is nothing but summation d squared, root of summation d squared by n, and s, which is root of summation d squared divided by n minus 1. So you should have a clarity on this part, where we are going to use summation d squared by n minus 1 and where we are going to use summation d squared by small n. So if the n which is greater than 20, then it should be sigma. If it is less than 20, then you have to go the formula S. The next one is how we are going to calculate the standard deviation of the mean. So standard deviation of mean, which is nothing but the letter uses sigma m. Sigma m, if n is less than 20, then we have to go sigma by root of n minus 1. If it is greater than 20, then we have to go sigma by root of n. Then standard deviation of standard deviation. So what does it mean? Already you have the calculated value of the standard deviation. So that term we are using sigma m, that is standard deviation of mean. Standard deviation is either according to the value of small n, either it can be sigma or it can be small s. So the standard deviation of standard deviation, sigma suffix sigma, which is equal to sigma m divided by root 2. So what is that sigma m? Here refers your sigma m, which is nothing but the standard deviation of the mean. So if you are not having the standard deviation of the mean, then you couldn't able to calculate standard deviation of the standard deviation. So I think you got clear what is standard deviation, what is standard deviation of mean, then standard deviation of the standard deviation. Three things you have to notice. Next one is about the variance. What is variance? Variance can be calculated through square of standard deviation, and the letter we have used is b. So b, which is nothing but sigma square, or else we can call s square. So where we are calling sigma square, which is nothing but n is greater than 20. And where we are calling s square, that is n is less than 20. So this is how we are calculating the variance. The next one is about the probable error. So you all know Gaussian curve. Gaussian curve, which is Gaussian as well as we are having bell-shaped curve. You all know even our final year result, the grading result, the people used to calculate it using the bell-shaped curve. You would have got this bell-shaped curve. What is Gaussian curve? You would have noticed, I think so. So this probable error, which is nothing but we are just getting the value from the Gaussian curve. So the Gaussian curve, which is nothing but it consists of the splitted value. That means you will have a negative, positive as well as 0. So what the people used to do, they will take a line from the midpoint. So if you are taking at the midpoint, what will happen? You have a left set of reading and the right set of reading, right? From that plus or minus value, they used to go for the probable error. So according to our syllabus, you should know how we are going to calculate the statistical analysis. So you should know the formula. That is the reason I haven't gone through the probable error theory part. So this probable error which is calculated R1 which is equal to 0.6745 into sigma. If n is lesser value, that is if n is greater than value of 20. Here I have given 2, it is not 2, it is 20. Then probable error of mean which is nothing but R, that is gamma, which is equal to R1 divided by root of n minus 1. So that is how we are calculating the probable error of the one reading, that means single reading, as well as probable error of the mean value. So I have just given for 2 problems for the practice point of view. So please do it individually. So the first problem I have given, the following 10 observations were recorded while measuring a voltage. So they have given 10 values: 41.7, 42, 41.8, 42, 42.1, 41.9, 42.0, 41.9, 42.5 and 41.8. Out of which we are going to calculate the mean, standard deviation, probable error of one reading, then probable error of mean as well as span. So how we can calculate? So the x bar, that is what your mean, that is equal to summation x divided by n. So if you are adding those values, you will have 419.7, and here the 10 values are there. So the n which is equal to 10. So which is equal to, you will have 41.97. Next one is standard deviation. So here the number of value, that is what you got, only 10. So the value is less than 20. So I am just going to use the formula S, which is equal to summation d squared divided by n minus 1. So what you will get for standard deviation, you should know the value of the deviation 1. So we have to calculate the modulus of x minus x bar. So after getting d, so you have to take square root of that deviation. So while you are calculating those values, you are having summation d squared is 0.441. So while you are calculating the s, which is equal to root of 0.441 by 9. So standard deviation is 0.22 volt. Is it clear? I think. Third one is probable error of one reading. So already you are having the value of the standard deviation, right? As you got 0.22 volt. So that 0.22 volt which is multiplied with your 0.6745. So you have your probable error is 0.15. Probable error of mean 0.6745 into s divided by root of n minus 1. So already you have the value 0.15. So that divided by root of 9, you will have the value of 0.05. So you will have the probable error of mean which is equal to 0.05. The next one is span. What is span? From out of the reading, your highest value is 42.5 and the lowest one is 41.7. So while you are subtracting those two values, you can able to get the span. So span which is equal to 42.5 minus 41.7, you can able to calculate the value of the span. So your span value you got it 0.8 voltage. Okay. So from the while you are doing this problem, you can able to understand how to calculate arithmetic mean, how to calculate standard deviation, how to calculate probable error of one reading, probable error of mean, and the last one is span. Okay. So these are all some of the statistical analysis we have done for this particular problem. But this problem, they haven't mentioned the deviations. If there is a deviation, you have to change the formula. Okay. Thank you.